Okay, so we are still in 7.4. And today, one of the differences, whenever we look at our problem, usually the first thing we check for is we look for the least common denominator, and then we look for any restrictions, okay, and then we multiply through. Today, we're going to check for one thing absolutely first, even before we look for least common denominator. And this is going to make things, for some of them, it's going to make them a little bit easier, okay? So the first thing we're going to check for is we're going to check if any part of the equation can be factored. And we're going to do this before solving. It will make some of them easier, and it will make some of them doable. The other difference, and some of them we're not going to be able to factor at the beginning, but a lot of the ones today, once all the denominators cancel out and we're left with our equation to solve, we're going to have to use factoring to solve that equation, which is the difference today, which is what we were doing before Christmas break. Yes?
Is that why it takes so long?
Yes. There's just a lot more steps. Now, one thing I will tell you today, the more work you show, I guarantee you the less mistakes you make, and I guarantee you the easier it is. A lot of people are trying to do too much in their head and they're not writing enough down, and you're making silly mistakes when you're doing that. So the more you write down, I promise you the less I almost guarantee you the less mistakes you will make and the easier it becomes. Okay, so as much work as I show up here, that's almost as much as I expect you to show in your homework, and it gets a lot easier once you see all that written out. Okay? All right, so first one. Like I said, I only have 3 examples. Let's do 3 over x minus 4 plus 2 over x squared minus 16 equals 0. Okay, now before we used to jump right to doing the least common denominator, but today we're going to look and we're going to check if there are any parts of my equation that I can factor. We are going to do that first. So look at all the different parts of this equation. Is there anything that can be factored? Yep. Gabe?
4x. Or like,
I think you're on the right track.
The x squared minus 16.
Right, it's a difference of squares. I have something squared minus something squared. And when I have something squared minus something squared, I take that something and I add it and I subtract it. So that x squared minus 16, I can rewrite that as x plus 4, x minus 4. Okay, one way this makes this easier, before if I was going to do my least common denominator, I would have had to say x minus 4 times x squared minus 16. Right? You would have to multiply them together because that's the only thing they would have been able to get rid of both of them. But looking at this now, what would I multiply by to get rid of all of my denominators?
X minus 4.
Yeah, x plus 4, x minus 4. I have to multiply by less things. When multiplied by x plus 4, x minus 4, that will get rid of all my denominators. Okay, and once again, before we start, we need to find any restrictions, meaning, is there any value of x that would make any of these denominators 0?
4.
Okay, so x cannot be 4. Anything else?
Negative 4.
A negative 4, right? You have to take into account both of these factors here. So if x is 4, it would be 0. If x is negative 4, it would be 0. Yes?
Can you write like x cannot equal the absolute value of 4?
Absolute value of 4 would only be 4. And this isn't really part of your answer. This is only for your use. So whenever you get down to your final answer, you can check. That's really the only thing this is for, because it doesn't really go in your answer. You guys have seen that. This is just so for you to check your answers. Okay, now that we have factored everything, we have the least common denominator, we have our restrictions, we're going to multiply. So this is the step that I would not skip. I would write all of this out. X plus 4, x minus 4, times 3 over x minus 4 plus, and then x plus 4, x minus 4 times 2 over x plus 4, x minus 4. And then 0 times x plus 4, x minus 4. But what happens whenever you take 0 times anything? You get 0. So we don't really need to write that out. Okay, once again, I would not skip this step. The people that skip this step are the people that are making silly mistakes. Okay, so write this step out. Okay, and now this is the exact same. So go through, cancel things out. The x minus 4s cancel out. The x plus 4s and the x minus 4s cancel out. So for that first one, I have 3 times the quantity, x plus 4. For my second one, everything but the 2 cancels out. And on the right-hand side, I have a 0. Okay, and to solve this one, I don't have to use factoring. I can just use our regular method. So if I distribute the 3, I have 3x plus 12 plus 2 equals 0. 3x plus 14 equals 0. Subtract 14 from both sides. 3x equals negative 14. And then finally divide both sides by 3. You should get negative 14 thirds. And double check, my restriction said x could not be 4 or negative 4. Negative 14 thirds is neither of those, so this would be an acceptable answer. Okay? Now this one wasn't a whole lot different from the ones we did last week. The difference is today, the next 2 problems, and then most of the ones on your homework, when we get to this step, we are going to have to use factoring to solve these equations. It's not going to be this easy. Okay, but the rest of it should be the same. Okay, questions on the first one? Nope. All right, moving on. Number 2. 2 over b squared minus b minus 2 over b minus 1 equals 1. Okay, very first, before we do the least common denominator, before we find our restrictions, can anything be factored?
Yes.
Or maybe, even if you're thinking of maybe, what one maybe can be factored?
B squared minus.
Okay, b squared minus b. What do we check first when we're factoring?
They're squared minus. Oh, greatest common
Greatest common factor, right? Do b squared and b have a common factor? A b. And I'm left with a b minus 1. So I can factor that b squared minus b into b minus 1. Once again, notice that this makes my least common multiple easier, right? What could I multiply by that would get rid of all of my fractions?
B minus 1.
B times b minus 1, right? We have to have both of those. Okay, now this one with your restrictions. This one you have to be kind of careful. One restriction is pretty obvious, right? What would b have to be for the second denominator to be 0? Okay, so b cannot be 1. Now, for this one, we have to take a little extra caution because let's look at this. If b times b minus 1 equals 0, if I multiply 2 things and I get 0, the only way that's possible is if this is 0 or if this is 0. Remember doing this before Christmas break? Okay, well, if b minus 1 is 0, b is 1. We already have that one. But I have another restriction, don't I? Because if b is 0, that would also make this denominator 0, right? 0 squared minus 0. So I have 2. B cannot be 0, b cannot be 1. Okay, makes sense? Okay, so same next step. Go ahead and multiply by the least common denominator. So b times b minus 1 times 2 over b times b minus 1 minus b times b minus 1 times 2 over b minus 1 equals b times b minus 1 times 1. And go ahead and cancel out your denominators. So for that first fraction, my b's cancel out, the b minus 1's cancel out, and I'm left with 2. For the second fraction, only the b minus 1's cancel out, and I'm left with a minus 2b. And on the right-hand side, nothing cancels out, so it's just a b times a b minus 1, and then times 1 doesn't really do anything. Okay, now this one, and this is what's kind of new today. For this one, I can't use regular methods to solve this equation because if I look what happens whenever I distribute that b, I end up with b squared minus b. If you ever end up with a squared variable, you are going to have to use factoring to solve this equation. Okay, so notice how I have the b squared, not just b's. Okay, so think back, and it's been a long time. I have an equation that I'm going to have to solve by factoring. There's two things that I had to make sure of, and they had to do with the zero product property. Those had to do with the two things before. What's the first thing I had to make sure of before? Okay. I'm going to use the zero product property. The first part is the zero part. Where does that come into play? What do I have to make sure of first? Has to equal 0. Okay, it has to equal 0. Now here's another thing. Not only does one side have to be 0, but this squared term here has to be positive. Okay? And today, a lot of times that squared term isn't going to come out positive. So you have to make it positive. Now, it's already positive, isn't it? Yeah. So don't move it anywhere. Don't move it to the other side to make it negative. Leave this squared term where it is. Move everything else to the other side. So to move that 2 minus 2b to the other side, I'm going to subtract 2 and add 2b. So subtract 2 and add 2b. Now on the left-hand side, I have 0. And on the right-hand side, I have b squared plus b minus 2. One other thing before we move on. Notice that it's in order. I have b squared and then b and then your constant. Always make sure it's in order. You'll save yourself a lot of trouble. So two things. Your squared term always has to be positive, and second, needs to be in order. Okay? Now, we're ready to factor this. It's set equal to 0. I need to factor. So, is there a greatest common factor? How many terms? Okay, so going through a factor flowchart, there is no greatest common factor. I have 3 terms. Do I have a square in front, square in back? X squared or ax squared? X squared. So we're going to look for factors of C that add to B. So factors of a negative 2, not a negative 12. Factors of a negative 2 that add to 1. What multiplies to give me negative 2 adds to give me 1? Negative 1 and 2. So this is the easy one to factor, remember, because we just do B minus 1, B plus 2. Okay, and then once it's factored, set each factor equal to 0, because if 0 equals b minus 1 times b plus 2, the only way that's possible is if b minus 1 equals 0 or if b plus 2 equals 0. So I have two answers. B could be 1 or b could be negative 2. What? What's wrong with that?
It can't be 1. Come on.
Very good. It cannot be 1. It's not no solution because I have another answer, don't I? I had two answers, right? Because I said that b could be negative 2 or b could be 1, but we said at the very beginning that it can't be 1 because if b is 1, it's going to make my denominator 0, and then the whole world's going to end. So our answer would just be negative 2. Make sense? Mm-hmm. Okay, last one. I know, but isn't it so fun? It's all with your negative 2, right? Negative 2? Yeah, negative 2. Okay, number 3. N plus 1 over n plus 2 minus 10 over n squared minus 4 equals 0.
You can factor the n squared.
Very good. The part that's new today, we want to make sure that I can't factor anything. And then we did point out that, yes, I can factor that n squared minus 4 into an n plus 2, n minus 2. Nothing else can be factored, so we're ready to do the least common denominator. What would I multiply by to get rid of all of those denominators? Very good. N plus 2, n minus 2. And what value of n, or values of n, would make my denominator 0? 2 and negative 2. Okay? Okay, what I want you guys to do, I want you to go through and multiply by your least common denominator, cancel out your denominators, and then I want you to stop because the next part will be different, okay? Okay, so once you multiply by your least common denominator, for the first one, the n plus 2 cancels out. You're left with n minus 2, and then you saw that n plus 1, right? So we're multiplying these two together. For the second one, both of them cancel out. You're left with the minus 10, and then on the right-hand side, when you multiply by 0, it just stays 0, okay? So from this point, we're ready to solve, okay? So solving equations by factoring, remember we're going to use a zero product property. First part of that, the 0 part, is it set equal to 0? Yeah. Okay, second part is the product part, meaning is it factored? Kind of, right? That n minus 2, n plus 1, that's factored. Is this minus 10 factored? No, it's not. Okay, so if this happens, and what you're going to have to do is you're going to have to multiply this out because we're going to have to refactor it because it did not include everything when we're factoring. So if I multiply this out by foiling, I would get n squared, and then n times 1 minus 2n would give me minus n, and minus 2 times 1 gives me a minus 2, and then I have that minus 10. Okay, so if this happens, if it's some of it's factored but not all of it's factored, you're going to have to multiply it out, combine like terms, so n squared minus n minus 12 equals 0, and then you're going to have to factor it all over again. Okay, so I have no greatest common factor, I have 3 terms, there is no square in front, square in back, and I have x squared. So we're going to look for factors of c that add to b. What multiplies to give me negative 12? Adds to give me negative 1.
3 and negative 4.
3 and negative 4. Okay, so this is the easy one to factor. We're going to take n plus 3, n minus 4. Okay, once it's factored, set each factor equal to 0. So n plus 3 equals 0, or n minus 4 equals 0. So n could be negative 3, or n could be 4. Are both of those answers okay?
Yes.
Yeah, they are, because at the very beginning we said it couldn't be 2 or negative 2, which is neither one of these. Okay. Any questions?